I started my project and I thought about earthquakes. And I thought, well, we could do buffer zones, Madrid fault right here. That kind of got tricky, so I kind of backed up and punted a little bit. But we decided it would be best to do some data from one of the sources Dr. Rubal had. So I decided we would look at this in this way. The earthquakes seem to be getting stronger, and they come more often. So I decided on this project I'd do just to kind of look at it and see if that's exactly the way it is. So I got some data from the years of 1973 to 1998, and so that's 25 years. So I decided we'd change things up a bit and look at it in 5-year increments, and to see if they were getting deeper and stronger. I also kind of did this in a different perspective because my boys, while I was doing this, were looking over my shoulder trying to find out exactly what I was doing. So for my presentation, I'm going to try and do it as teaching somebody how to do it. Whoop. Okay, here we go. So I got on the right here, I've got a screenshot of my data that I downloaded from Esri as well. Well, education community is where I got most of the data. National Atlas, National Map, and then also the census, the Tiger Census data from 2007. So, what I did is took all those years, sorted them by attributes, by the year, and separated them into 5-year increments. So, all the brown lines on here are the faults, and all the blue lines are all the earthquakes that happened in those 5 years. This is from 1993 to 1998. And I went backwards. There we go. So, I added the states shapefile on here. And I got Hawaii and Alaska on here. So I did that. Anyway, I added the state shapefile, changed the fault lines to red, and played with the colors a little bit. And that way it was easier to see and to view. Then what I did is I went through, and it's kind of hard to see on the snapshot here, but I sorted by the attribute named magnitude. So I went through and changed everything, and I decided I'd go magnitude 5 and higher. Well, that was a little difficult to get through all the data, and it was a little hard to read. So what I did is I went through and sorted the data by magnitude I went through and selected by attribute, and also got the statistics of all those earthquakes. And I got the mean, I also got the maximum, the minimum, and also did that for the depth of each 5-year period as well. So here is a snapshot of the years of 1973 to 1977. There were 2,389 earthquakes just in those 5 years. The magnitude is measured with the seismic scale, and the depth is measured between 0 and 700 kilometers. Let's see, the intermediate earthquakes are between 70 to 300, and the deep are 300 to 700 kilometers deep. So from 1973 to 1977, the minimum magnitude was 4.0 in my attribute table, and also the maximum through those 5 years was 7.6 magnitude. You're going to see through all these slides that the minimum depth is going to be 0 because of surface quakes. And also, the maximum depth is 232 kilometers, which, if you look, it's intermediate. So for the years 1978 to 1982, there were 2,662 earthquakes. Again, minimum 4, maximum was 7.4, and the mean or the average is 4.579 for the the magnitude, so it's not real strong. And then the depth, 246, so it's a little deeper, but the mean is only 29.3. And then the next 5 years, 83 to 87, there were 3,269 earthquakes. Maximum was 7.9, but again, the mean was 4.63. 260, getting a little deeper, getting a little stronger, and the mean on the depth is 29.95. The next 5 years, maximum 7.6, mean 4.59. 274, getting a little deeper yet. So here we are, 1993 to 1998, the end of the 5 segments. There were 3,237 earthquakes in those 5 years. Maximum 7.9, the mean's 4.5. The maximum, though, is 300, even deeper yet. But our mean stays about the same. So what I did is I decided to go through what I've already sorted out some more. So I took magnitude of 6.5, which seems to be where the damage occurs the most, the bigger the earthquake. And then the depth, I did deeper than 19 kilometers. So I get rid of the surface quakes and things like that. So for the years of 73 to 77, I got 4 earthquakes at a magnitude 6.5 or higher. The maximum was 7.5. The depth was 27.25 for a minimum, at maximum 47. And I go through these years, 78 to 82, another 4, 6.5, 7.1, 20. The maximum depth is 45.33. 83 to 87, only had 3 that were above 6.5. Got to count 320 minimum, maximum was 33. There's our 7.9 magnitude. Here's 1988 to 1992. There's only 2 that were above 6.5, with the minimum of 6.6, maximum of 6.8. And your maximum depth was 28.25. Now, here we get a little more interesting. We got 32 for 1993 to 1998, the last 5 years. We've got a minimum of 10, maximum of 40.375 on the depth. I kind of switched those, I just realized that. And then my magnitude, 7.9, but the mean is 5.6, which is a little more. So here's a snapshot of my query, or my summary, or the attributes, I'm sorry. There's a lot of data in the table. I tried to get it all on the screen there. And other attributes, I sorted by the year and the month and the day. That was how I could get the 5-year increments. And I figured this data could be really meaningful to the insurance industry. I'm sure there's different ways they do it now, but somebody that could centralize all this data into one place for them, it would be very helpful for them if they knew where all the fault lines and everything was. But the biggest thing is, I found in my research that the USGS actually has a program like this to predict potential damage from earthquakes, hurricanes, and floods. And it's called HAZUS, H-A-Z-U-S. And they are basically doing my project. But in conclusion, the earthquakes have become more abundant and stronger. What we just saw with the Japan earthquake causes major damages and way too many deaths. So, that's it. Any questions?
Does anybody have any questions? What type of data did you, was this all vector?
It was all vector.
What would have been a powerful way to take, instead of taking each one of those time intervals, what could you have done with all that data to clamp it in one visual to actually answer the question on some sort of trend analysis? Have earthquakes become more frequent and have they become deeper and stronger? He could have taken all that data and collapsed it onto one what? You could put it into Excel and just simply did what with that data?
Yeah.
You could have done a trend line, and just graph the data, and you probably could have saved numerous